In this video, we are going to cover the benefit of function blocks used in Mitsubishi Melsec GXWorks3. I will explain to you why the use of a function block is a big benefit for you in programming. How do you use the function blocks? How do you create a function blocks? How do you implement a function block in your program? And also I will show you how you can monitor the function blocks. So I made a small example for you using the function of a cylinder that moves back and forth. And as you can see, I created two letters of programming code that is using three inputs. The one input is the cylinder forward, the other input is the cylinder backward, and the third input is the cylinder off, and also an interlock. So if you push both inputs at the same time, your function will be interlocked, and also the forward and backward function right here. So I turn on the simulator for you, and you can see the individual inputs down here in my watch window. So as you can see, first of all, I got a switch on the off input. This is just made for safety reasons, because if you lose the hardware signal, your cylinder automatically goes off. And then you will see this turn on, and then we go to the forward function, switch that one on, and then you can see your output moves your cylinder forward. And if you want to do the same thing backwards, you switch the forward off and you switch the reverse on, and then it will change your direction. And if you switch it off, both signals will go off. So this is basically the function of moving a cylinder back and forward. And if you now want to use a second or a third cylinder, you will have to go ahead and copy this whole program code and double it up, and then you will go ahead and have to change all your addresses. If you just say, let's say it was 13, the last one was 12, now you go to input 13 for the forward. The input 14 will be the reverse or the backwards, and the input 15 will shut it off. And the same on here. Now you have to be careful, you have to use the input X12, the input X14, and the input X13 for the interlock, and also the input X15 for the off function. Also, you want to change your outputs to, let's say, output 12 and output 13. And for the latch of the cylinder, you will use also the Y12, and you will use the Y13 for the backward position. So if you just put a stopwatch on the video, you can see how long it took me just to implement this second cylinder function in the program to make this to work. Now, what would you say if you can cut this time easily in half? So therefore, I created this function block, which actually contains the same programming code that I have in here, and you can easily copy this with this, copy that, and then you just put in here your local label, your next local label for the cylinder 2, and then you can do the same thing on here. So if you see on the cylinder 1 it was X012, and this can easily be changed to X3, X4 and X5, and the output will be easily changed to Y2 and Y3. So this is how easy and fast it is to implement your next function or your next cylinder back and forth. So you can see this was like at least half the time, if not less than that, and you can implement this. Just go ahead by copy and paste it another time, and you can just see how blinding fast this programming goes. So still in the 3, and then just go ahead and change your inputs X6, X7, X10 because it's octal, and the Y4 and 5. So now we just programmed 3 cylinders in no time. And how this is actually working inside this little block, you can see the inputs going to a bit here, and the outputs also. And now if we open this block, we can see it is the same programming code that I used in this programming when I do it individually. See right here, this is the same programming code, only you got your inputs and your outputs inside a small block, which is basically the same like a small PLC itself. It's an input and an output, and you can see this on your local label. You can see the forward, the backward, the stop being used as a bit with a variable input and a variable output. And this variable input and variable output is used on here again, and it works just the same way it does here with the in and output hardware signals. So how is this block being created? You can just create another function block on here. I will call this whatever, just cylinder for whatever example. It doesn't matter. You can give this any name that you want and make it a function block. You can choose this on here. Which function do you actually want to make? You want to make a function block, and the program language, excuse me, the program language is used as a ladder file, and the FB file, this you can use just as a subroutine, and then you're all set. You push OK, and then your block is getting created. You can see this here, and if I close all the other windows, then you can see here is the code written, and then here is the label name, which we can just go ahead and say an in label bit for cylinder forward, which is a bit, and very important, you have to choose the variable input. because this is an input just like I showed you, and then you will see, you will write either reverse, it doesn't really matter, or backward. Make this also a bit and also an input, and copy this again and just write cylinder stop. Also a bit, and also an input. So now you want to write this to an output where you write out, also bit cylinder forward. This is also a bit. And it's a variable output. And then I'm just gonna go ahead and copy it because it's too much writing, copy paste, and then you just write here reverse, and it's also an output. So now you got your labels for your function block created, and now you can go ahead and create your program. Here you put in B, and then you can also see it suggests you already your labels that you can use. One moment. B cylinder forward, okay, and not in B cylinder reverse. Make this a not, a normally close contact, and you want to make your normally open contact for in bit cylinder stop, because this way you have to have a high signal in your hardware input, just in case you got a wire or you got a hardware failure, then your input is not read, and then it will switch automatically off. There you go. And last but not least, an output. That's why I say you write out and in, so it's easier to find. And you make this a coil, and all you need to do now is make a parallel run with the latch from the out forward, and then you're all set. And you can copy and paste this, and all you need to do is you write reverse on here, reverse, and forward on here. Cylinder forward on here, and also cylinder forward, cylinder reverse, reverse on here. And then you can copy this and paste it in here for the latch. So this is how your function block is created. You can save that. And now just for example, we make, we put this in here in our function that we already have. So now how do you actually implement this function block in your programming code? So you just have this name on here, and you go to your element selection and type in the name cylinder, and then you should find it. If you go down here, now where is it? function block. There it is, function block, cylinder for example, there it is. So you just drag and drop this in your program right here, and then you will see an instance name is created, and this instance name is created in the local label, where you can see it on here. Every block needs an instance to memorize its internal data. So now we have placed this, and all we need to do now is give it some inputs. Let's say we put in here x20, make it x21 on here, and for the stop x22, and just put it over to the power line. And the same here with the output. We say output 20 for forward, and the output 21 for the reverse. And if I made everything right, we just convert the program or rebuild the program, and then we make a simulation. Simulation is running, and now we can say x20 for the forward, x21 for the reverse, and x22 for the stop, and y20 for forward, and y21 to move cylinder backward. So if we go ahead and switch on the x21 to high, you can also see this little green square is turning on, and this is how you can actually monitor. So now the output is not on yet because we do not have the x20 set yet. So if we set that, the output does not turn on. So what did we do wrong? We just go ahead, make a double click on here, and what did I do? I switched on the wrong output. I need to switch on, sorry, this is, now we can actually see that the interlock is working, and if I switch off the x21, we can see x21, the input for the cylinder backward switches off, and if we switch on the x22, which was the cylinder off function, we can see the output switching on, and we can see it also switch on in the actual program code, and then you can see how easy it is to monitor actually this function block. Okay, now we check the code of the program, and if we see that the code is correct, I'm just gonna try the reverse function. It's also working with the interlock. See, the Y21 switches off, the Y20 switches off, the Y21 switches on, and this you can see again. If you make a double click on here, you can see again it changed over to the out cylinder reverse. So now we actually checked the program code of the function block, and now what we want to do is we want to make our second cylinder. So we switch off the simulation mode. Actually only just copy the code and put in the cylinder, for example 2. If we put this in, we can see this in the local label being already written in here. So we have our next subroutine on here. And if we go ahead and just type in a 30, $31, $32, and the output is 30, and the output 31. And if we monitor this again, you will see in no time we added another cylinder to it. Oh yes, we have to convert the program. There we go. Simulation. There we go. And if we go, well, we should make this smaller right here, and then we put in the X30, the X31, the X32, and you can see if we switch on the X32, which must be on for hardware reason, for safety reason, and then we switch on the X30, the output for forward switch is on. And if we switch on the X30, if we switch off the X30 and switch on the X31, it changes from forward to reverse. And this is how easy you can create a function block. You see how much of your programming time is saved, and you can also test it ahead of time before you make it double or you copy it to another one. Test it out and see if everything is okay. And this is how easy it is to create a function block in the Mitsubishi Melsec GXWorks3. And thank you for watching.